Dang, Mr. Sprague, back at it again with the homeroom math. Welcome back, Onyate and homeroom people. This is the second installment of homeroom math. We apologize that it's been so long. We've had a little bit of a crazy schedule for these past couple of weeks. We are back. We should be back pretty routinely from here on out, so you can look forward to more math each and every single week. For Algebra 1, we are looking at creating these functions from tables, so we're trying to make each one of these tables, 1, 2, and 3, as equations. They are linear, which means they have a constant rate every single time. So we have a couple quick strategies that we can go through. So when we're trying to find the equation, it's really easy to find the rate of change. So how much is it changing every single time as x changes? And that's pretty simple. We're looking at our change in our y every single instance. And we're also going to compare our change in x. So what I notice here is that it changed from -3 to +2. Well, that's a change in 5. We also know from 2 to 7, well, that's a change in 5, and then that is a change in 5. So that right there tells us that it might be a linear equation, as long as this, our x column, also changes at the same rate. Well, that's changing at +1, that's changing at +1, and that is changing at +1. So now we can use our rate of change, because these numbers are the same and these numbers are the same, to help us write our equation. So we start by doing this. Y equals our rate of change, which is 5 over 1, and then multiplied by our x value. A lot of people tend to think that, well, since this is increasing by 5 every time, then it's going to be something like x plus 5. Well, that doesn't quite work that way. And we can see that if I take x and add 5 to it, it's not going to give me 2, or 2 plus 5, well, that gives me 7. That's good, but 3 plus 5 doesn't give me 12. But this does work, but we're not quite there yet. So we're taking this number, this rate of change, and multiplying by x, but we need to add or subtract something. So let's think about this. First, I'm going to simplify y equals 5 over 1x, and I'm going to simplify that down to just 5x. Now we know we're going to have something here, and our last goal is to figure that out. Well, if I take 5 and multiply by x, for example, if I take 1 multiplied by 5, I get 5. So I need to add or subtract something in this case. Well, it looks like I might need to subtract 3. Let's see if that works. 5 times 2 is 10. 10 minus 3 is 7, all right? 5 times 3 is 15. 15 minus 3 is 12. So it looks like we found our next number, and that's a -3. Now, we don't see it written as 5x plus -3. We actually see it written as 5x minus 3. So that's our equation for our second or our first table. Our second table, we're going to look at the same thing, but it's a little different because, well, it looks like this is going downwards. So that's -2, -2, -2. This one is increasing by 2. So our rate of change compares our y's and our x's. So we're going to start with this. Y equals our -2, which is our change in y, over our change in x, which is +2, and we multiply that by x. And again, we're going to need to add or subtract something from here. That's okay. I'm going to simplify this. -2 divided by 2 turns out to be -1x. And now again, we're trying to figure out what number I can put here to make this equation work always. So let's try some numbers here. Let's take 0. Y equals -1 times 0. Well, -1 times 0 is 0. 0 plus what would give me 6? Well, 0 plus 6 would give me 6. So that's a possibility. Let's see. 2 times -1 is -2. -2 plus 6, well, that gives me 4. So we're good. 4 times -1 is -4. -4 plus 6 is +2. Looks like we found our last number. So my final solution looks like -1x plus 6. We're going to repeat the same process over here. Our final answer, I'm not going to go through it too much because we are done, turns out to be, and that looks kind of creepy. Our final answer looks to be like y equals -1/2